So we are now recording. Okay, everything should be okay. All right, so now let's let me share the screen. We're gonna take a look at Brightspace first. Okay, so today, so if you remember, on Tuesday, we went over this module, security axioms, really just had a short lecture on, some of the ideas of systems assurance. Basically, since we're going to be looking at the network, right? So that's really our field of interest. Our goal is to not, we're not in the business of attacking, but we're in the business of defending, providing cybersecurity, right? So we are going to be looking at the network, right? So, and as I said, when we talk about the network, there's two things. There's obviously the network system links, right? The architecture, how it's built. And there's also the data itself that's running through the network in the form of network packets. So along throughout the semester, we're going to have to process packets, right, to deal with them. So today, next week, we'll start getting into some of the labs and some of the issues. Today, we'll have an introduction to a very important library. One of the tools that we will use several tools for this course, but we are going to look at the Python Scapy library. Okay, so I'm going to click on this. So if I click on this module, basically we've covered that. And now I'm going to take a look at this module over here. And, you will have your first homework assignment, which should be an interesting, simple assignment. Okay. So that you'll have to kind of figure out. It's just one problem that I'm going to lay out. And it'll be a problem that allows us to start to develop an understanding of how Scapy works. So what is Scapy? As I said, we can actually go, I will provide a link in the schedule for this, the documentation, basically, introduction to Scapy. So Scapy is a Python program that enables the user to send, sniff, and dissect and forge network packets. This capability allows construction of tools. Let me see, just make sure you guys are seeing this. Yeah. This capability allows construction of tools that can probe, scan, or attack networks. And so really, that's kind of where we are. We're going to be living in this course, right? So, if you want to understand an intrusion detection system or a firewall, the first thing you have to understand is that they are initially a sniffer. And so we want to understand under the hood, if you will, how they work. And so that will be our objective. So today, my goal is simply to go over this. As I said, I'll provide this link so that you guys can take a look at it. Also, the book has some great material that you can reference. So in other words, Scapy is a powerful interactive packet manipulation program. It is able to forge or decode packets of a wide number of protocols, send them on the wire, capture them, match request and reply, and much, much more. Scapy can easily handle most classical tasks like scanning, trace routing, probing, unit tests, attacks, or network discovery. And it can replace a lot of those tools like HPing, ARP spoof, and all the other ones. And even some parts of things like Nmap, TCP dump, and TS shut. So the idea is, and the reason being that really a lot of this is built on top of a library in C++ called the libpcap library. So we'll take a look at that at some point. But all of these tools are basically built on top of that. Remember that anything that deals with the network needs to be fast and efficient, right? And so these tools are built on top of C++. As you know, Python is an interface to, can be an interface to C++, so it can be very efficient. So, there's a lot of things that we can do with Scapy, and this semester, we'll be using it throughout the semester to kind of figure out and learn a few things. A lot of things. So we will be able to spoof packets, inject your own. You could inject your own 802.11 frames, do combining techniques like ARP cache poisoning and VLAN hopping, and things even related to these more advanced ideas. Okay, so the idea is simple. Scapy mainly does two things: sending packets and receiving answers. So you define a set of packets, it sends them, receives answers, matches requests with answers, and returns a list of packet couples, request and answer, basically, and a list of unmatched packets. This has the big advantage over tools like Nmap or other ones, that an answer is not reduced to open, closed, and filtered, right? So you have literally the packet itself. So that's the beauty of this, is that we will literally now be able, through very easy. So if we want to take a packet that we've captured and break it up into the headers in C++, that can be a little bit involved. We'll actually do a lab that kind of shows it in that sense, but here it'll be a lot more straightforward. Okay, so that's really the idea. Okay, so that you can read through the rest of this. It should be pretty interesting. But basically, I just wanted to motivate, what is Scapy? There's a lot of advantages, like, for instance, fast packet design. One of the tricks that we can do with Scapy is we can capture a packet, copy it, modify a couple of fields, send it back out, right? So we will be able to do a lot of little neat tricks like that. So we'll work on it. Right, so you can basically here you can follow along with all this. So today my plan is I will simply go over the code. Okay, as you see here in this, I'll provide some examples of how things work, and then you guys can also read through this. I would say that the more you understand Scapy, I certainly, like in the past, for instance, right? I've taught this class in the past, and I made the mistake probably when I taught the class that time that I didn't do an intro to Scapy first. And so it'll be harder for you to be able to solve the problems, if you haven't really thought of Scapy as a separate entity that you should have command over. So I definitely recommend that you go through this. Plus, I will be doing some examples, some discussion of how Scapy works. And so that, hopefully we get through the software. Okay, so let's go ahead then, since I've kind of motivated this. Let's go back to Brightspace and let's just take a look at the document that I have on here. So this document, I will be adding a link for the assignment. All right, so but let's just click on it right now. All right, so as you can see here, we've got a couple of tools that we might need to install. You can see them here. Obviously, Scapy. Now, the Ubuntu 2004 seed already should have it. So that's an advantage of using it. However, if you're using your own VM, you will have to probably install it. There's a couple of other libraries that you might need for the homework, which are visualization libraries. Okay, so as I said, there's a problem that you will have to, it's very, it's our first week, right? So it should be very straightforward. And really the goal of the problem is to get you to play with Scapy a little bit more. As I showed on Monday, you can go into Scapy and you can start it up individually, or we can also call it as a library into Python. Okay, and then I'll come back to talking about these things. Some of these are actually really neat. So when you play with this as part of the homework. But here you can see this is my usual just sequence of Linux commands that you should follow. Okay, and this is just kind of to get you to familiarize yourself with the code. Okay, so Instructor. Then after that, we're going to get into a little bit of the scripting examples with Scapy. So these are going to be some of my Instructor provided problems. I'll discuss it a little bit. And so on. And then this will be the homework assignment. So this will motivate so that we have something that we are working towards, okay? Okay, so let's take a look. First, before we actually start thinking about start running commands through Scapy, let's just read through this case, basically. We can call this like a network security case. And this is a classic example. You may actually have heard of this before. The goal is just to kind of think how Scapy could help us to solve this problem. All right, so before I begin with the case, are there any questions?
None for me.
All right, great. So the case is called How H.D. Moore Solved the Pentagon's Dilemma. So in late 1999, the US Pentagon faced a serious crisis against its computer networks. The headquarters of the US Department of Defense, the Pentagon, announced it was under a coordinate series of sophisticated attacks. And this is the reference. A newly released tool, Nmap, made it rather easy for anyone to scan network for services and vulnerabilities. The Pentagon feared that some attackers were using Nmap to identify and map vulnerabilities in the Pentagon's massive computer network. An Nmap scan proves rather easy to detect, correlate to the attacker's address, and then geolocate that IP address. However, the attackers used an advanced option in Nmap. Instead of just sending scans from their specific attacker addresses, they included decoy scans that appear to originate from many places around the world, right? The Pentagon experts had difficulty distinguishing between actual scans and decoy scans. While experts poured over massive reams of data logs with theoretical methods for analysis, a 17-year-old from Austin, Texas, finally presented a working solution. H.D. Moore, legendary creator of the attack framework Metasploit, met with Stephen Northcutt, from the Navy, the Navy Shuttle Project. So I guess I cut this thing out. So the question is, so hopefully that's enough to understand the problem. So now the question is, what do you think H.D. Moore did to solve the issue? And how would you solve this problem? Okay, so you're gonna basically, your homework is to write down, I'll change this, it's written kind of weirdly, but basically you just have to submit a report with evidence that you can solve it, okay? And this is gonna be based on Scapy. So then let's just talk a little bit more about the case, right? Just for a second. So what is the problem here?
They need to figure out what attacker IPs are legitimate and what are decoys.
Yes, that's it, right? So somebody is scanning the network, but they're spoofing some attacks, some IPs. So you want to figure out how to solve this problem, right? So H.D. Moore, he came up with a solution. And so now we just have to think, how would you address this problem? If somebody was attacking the network, you worked at the Pentagon, how would you figure out what were the valid, as Dakota said, the valid IPs? Okay, so this will be, as I said, your homework. Okay, so this will be due a week from today. And the next thing I'm gonna do is just work through some scripts with Scapy, give you some hints possibly, and then you'll be able to start thinking about this assignment and trying to solve it. Okay, are there any questions about the case?
I don't think so.
Sounds pretty clear?
Yeah.
All right, good. All right, great. So that sounds good. So then, as I said, this is the problem. Now that we have this problem in mind, okay, great. Now we have a motivation to learn this program, right? So because I am telling you, maybe Scapy can be helpful. Okay, so Obviously, I've provided a few commands here that might also help us out. But now let's go ahead then. We'll come back to this in a second, and let's just go to the virtual machine. And I have to start it, actually. I'm going to start my VM. All right. So let me share if I'm not sharing the VM. Okay. So you should be seeing it now. I'm going to log in. Okay, great. So I am now logged into the machine, and we're just going to start going over all right, some ideas with Scapy. So let's go ahead and I'm going to create a new folder. For the course. Okay. I'm going to open up a terminal. Just making sure we're recording. All right. So let's navigate to the desktop. Okay. All right, so the first things we're going to do is if you had to install Scapy, let's say that you have to install it on your machine, you would do something like sudo. This would be for 2004, so pip3 install Scapy. Okay. All right, so I already have it, but if you don't have it, there's the command for that. Okay. If you're having issues with pip install, you could also update it, or if you don't have it, you're going to have to install pip, which is a way of installing things on for Python. All right, so let's start creating some basic scripts then. All right, so the first thing we're going to take a look at is creating a simple script of how things should work with Scapy. All right, so we'll create our first one. Let's just call this one let's just say IP packet. So remember, packets are made of Ethernet. So actually, I should just I know you guys probably know this, but just as a reference, remember. Let me go to the whiteboard. So in the network, right? You guys learned some time ago. You have your network packets, right? Just a quick. This is a quick refresher. So a packet has headers. This is usually called the Ethernet header, where the MAC address is located, things related to the low level of the packet. Then you have the IP header usually. Then this will vary. You might have an ICMP header, UDP header. And usually a lot of the things we'll be doing in the class are either going to be TCP or ICMP. And then when you have a TCP header, you also usually have a payload, where the payload is the data that is being carried, right? And this may be variable and bigger. Okay, so what's great about something like Scapy is that it will allow us to break up things, right? Or make a packet just from the header. So a lot of things, a lot of the time we'll be able to create objects that represent an IP section or a TCP section or a payload section and so on. Okay, and so that's what we want to kind of do right now. So let's go ahead. Let's go back to the script. Okay, I'm going to create a simple IP example.py. Okay, so just some name here. Oh, and need to make sure I'm sharing. Yeah. All right, so let's open this one. All right, so here we are. I'm going to add, if you want to make it executable, remember you can do something like this. Bin, just to kind of specifically tell it to use Python 3. Okay. Then we are going to import the library. So from Scapy.all import all, basically. Keep it simple. And then now creating a packet can be as simple as just that, because we are using Scapy now. And that just indicates that we have a an IP header there, and then we can do a.show, which should allow us to view things. So I'm going to hit control. So this is our first example. So Control X, Y, enter. So I've created the file now, IP example. Okay, so now I'm going to right. So now I'm going to go ahead and we can look at the file. Right, so let's try running the script. So I'm going to do sudo. No, actually, let's do it without sudo. So I'm going to do Python 3. So I haven't made it executable. If you look at the permissions, it's not executable yet. So Python 3, and I called it IP. So I ran it, and there you go. What do you guys see? We created an IP header, right? Notice that it's got all the fields of an IP header. This is really important, guys, because when you're either spoofing or sniffing a packet, right? So you're spoofing, which basically is going to mean, at least for the class, our discussion means taking a packet for that should not be there. So a bad packet in some way, maybe an attack, maybe whatever it is that causes unexpected behavior. Or whether we're doing defense and we're trying to detect packets, the things that we're going to look at are these fields. So there's the TTL, right? Proto, checksum, source, destination. Notice that some of these values are default because we can actually modify them. It's got flags and so on. And some of these fields are probably useful or needed even for you to solve things throughout the semester, including the initial case that I've given you for the homework this week. Okay, So that's basically it. So we ran we created an IP header, we ran it, we looked at it. Are there any questions?
I don't think so.
Making sense, right? So pretty simple, really. Okay, so we have there our idea of how Scapy should work. Okay, so we've created that. Also, you can make it executable, although I'm not gonna. You should know how to do that. So let's take a look at. Let's take a look at another example. This one is a generic sniffer. Okay, so what is a sniffer? Sniffer is something that is going to be listening on the network interface for packets coming in, and it's going to decide, okay, do I do something with this packet or not, right? So there's got to be some logic. So now we're going to go ahead and create another script. This one, I'm going to call it plain sniffer.py. There we go. So in this case, I'm going to say from Scapy .all import all. Okay, so I've got the library. Now, what do I need to do? I need to create a sniffer. So I'm going to do pkt is just a variable that basically says I've captured a packet or I've captured some response. And then I'm going to say sniff, which is the built-in function for sniffing the network. And here I have to specify a couple of things. I'm going to specify a filter. So I'm going to specify a filter, which basically works a little bit or a lot actually like how Wireshark works. So in Wireshark, you put in commands in the text box, and it allows you to filter things out, right? So it's the same idea here. So for instance, let's say that I'm going to do ICMP, right? And so what does that mean? It means that I'm going to look for packets that are only ICMP. Can you guys give me an example of an ICMP packet?
Like a ping request.
Ping request, right? But we have ping echo request, echo reply, and so on, right? So all the fields are going to become very important for that idea. All right. The other thing that we need to figure out is what do we do with the packet once we capture it, right? So when we sniff, what do we do? And so in this case, we're going to say prn equal, and then we specify a function that we're going to write for this. So I'm going to say, for instance, print pkt. Okay. And so now I need to, of course, define what this function should look like. So I'm going to say define print underscore pkt, and the input to pkt is going to be the packet itself, right? So you can see that there, pkt. So colon 1, 2, 3, 4. Remember the indentation in Python, and then what do? Just like we did in the previous example, pkt.show. Does that make sense? All right, so that's an example of how this pipeline works, and this pipeline is actually pretty consistent. It's pretty consistent in the sense that you have the function that's kind of like listening, sniffing, and then you capture a packet based on the filter, and then now you can write any code that you want here to decide what to do with that packet. So as we progress in the semester, we're going to be learning more and more things that we can add on to these. But for now, I'm just doing pretty basic. So I'm going to go ahead and save it. And there you go. So now ls-l, and I have now my 2 scripts. Okay, so now what can I try to do here? I'm going to try to run the code. So I'm going to do Python 3 plain permission error. What would you guys suggest I do?
Sudo.
Right? Yes. So then I'm going to do sudo here. Okay, and now it seems to be doing something, right? Why do you think I had to do sudo? What would be your reasoning for something like that? What do you guys think? What happens? So what's happening here is that remember what Scapy can do. Scapy can actually create packets and send them into the network. So do you want to do a denial of service attack on a machine? Sure. Generate a for loop, send multiple packets, right? So that is probably something that should be controlled somehow. And usually this is restricted to having the root privilege. Okay, so that's an important concept. Okay, so now we've established that this sniffer is looking for ICMP packets, which are ping packets. So now I ask you the following question. How do we establish in the code that it would print whenever it would print information about that packet whenever it detected ICMP. So now how can I get it to sniff some ping packets? What do you guys think?
Ping something.
Ping something, right? So I'm going to go ahead here and open up another terminal. Okay, maybe move it down here. And so now I'm going to say ping and then www.google.com. And there you go. You see that the second that I started pinging over here, you can see the output starts to come out, right? It's now capturing ping packets, right? And you can see it's giving you the IP. So if I don't know if you notice, this is the IP header. It's giving you the information about the IP header. This is the ICMP header. This is the raw data that it's sending. And so you can see these are it's capturing echo replies there. And so now we have a means of capturing our network data. We know we can extract it from here. So this gives us the possibility of doing some analysis, right? And the question though is how are we going to do this kind of analysis? Okay, so this is the basic idea for this script. So I'm going to go here now, do this, and I'm just going to stop it, of course. And I'm going to exit the terminal actually. All right, good. And then this one stopped because it is now not, it's not sniffing any traffic basically. Okay, I'm also going to stop it now. Clear. We have our script. We can, and then somebody asked a question. Okay, so I'm going to go back to the code. So let me just up arrow here. And there it is, plain sniffer, and you guys can take a look. So definitely, as I said, this class should be, I'm gonna try to give you, not the answers necessarily, but I'm gonna always try to give you like the code, the building blocks, so that you can use it for your own examples or problems that you need to solve, okay? So I'll just leave it up there. Now we saw how to do ICMP packet captures. Is there a question? Okay, great. Now let's take a look at just a slight modification, right? So obviously we can print out, in this script, we can write anything that we want in here. And these, as I said, these filters, this is very useful because it's a lot like Wireshark. And so you can do things like, for instance, if you're doing TCP, let's say you want to do TCP and something else, then you do AND. You see that? And so you specify another field like maybe an IP address. So you can do that. You can specify port number. So you can say TCP port 80, right? Port 80. So you can capture that type of traffic. Always think of this as the device that's looking, right? So the device is looking as packets are going by. So the second a packet goes by, it's going to look at it and see what it is. So here it would capture packets that are TCP port 80, right? Now, that's really the important thing. Now there's a difference between destination and source, right? So also if you want an IP, those are usually host, and then the IP address that is in that packet. So it might be like 192.168.1.17, for instance. Now these numbers, of course, have to be exactly what you have in your network, okay, guys? So they'll have to be what you have in your network. You'll have to get those addresses, etc., to make sure everything works. Now, how do you trigger certain services? So let me close out of here. So let's say that you're trying to capture telnet traffic. What is the port? What is telnet traffic? Tell me that. What is telnet?
It's like unencrypted SSH.
It's like an unencrypted SSH. Okay. Now look at it from the point. So obviously, when that service is running, packets are being sent. So what are some things that you can tell me about telnet related packets?
They run on port 23.
Port 23. What protocol?
TCP.
TCP. You see that? So that's important, right? So if I wanted to find those types of packets, then I need to look for precisely that. Now, let's say that you want to generate, telnet traffic. How would you do that?
Connect to something via telnet.
Connect, exactly. It is that simple. If you want to generate packets that are port 80, open a browser, send some traffic, right? That's it. It's literally that simple. You don't, my point is, sometimes you don't have to craft a packet with Scapy. You can, if you just need a port 80 packet, just open a browser or telnet and so on. Perfect. Very good. Right, so as I said, this is just a simple introduction to some of these scripts. All right, so now that's quick intro to that. Now let's go ahead and take a look at some of the information on Scapy. So we've looked at the function for .show. So that's basically anything that's like, pkt .show. So that just shows information about Scapy. We also looked at the function sniff. Okay. So we've got information about that one. So we have other functions like the functions. These are important. The functions SR, right? The SR function is for sending packets and receiving answers. So just make a note of that. So this function will allow you to send a packet and receive an answer. All right. So when you're pretending maybe to be something, right? You're doing an attack and you're pretending to be something, you can use this function. There's also a variation of that, SR1, which is a variant that only returns one packet that answer the sent packet. Okay, so SR1, and then, so that's the basic idea. Okay. So now let's think, how could we create, this is an important aspect, how could we create a packet? Like, let's say that you want to create your own packet. So I'm going to do nano create. And I'm going to say, because I'm creating it, anything that it's not generated, you know, by the computer, it's basically a spoof packet. So I'm going to say create spoof packets. .py. Okay, so let's go over here and take a look at how this would work. So, you know, basically it should be pretty simple. We have the following functions which represent the headers of a packet. So we have, for instance, IP, right? And then we're going to have ICMP, or we're going to have TCP. And it's really that simple. So every time that we make a call to one of these functions, we're actually creating that little piece of the header in the packet. So really, by default, Scapy will populate all the fields with usually the default values. However, there are some values that we can change. So for instance, we could do the destination IP, right? So then I'm just going to say DST equal, oops, sorry. DST equal, and then I'm going to plug in here an IP address. So I'm going to say 192.168.1.99, for instance, right? So we can do something like that. And then, you know, that allows us to specify just the values that we want. The rest become the default values. Now I want to create the packet. So I'm just going to say then, and actually sometimes people do this, although you can do it directly in the packet. You could do A, B, C, right? So then over here, when we create our packet, the format is going to be A /B/C. And it's literally that simple that we can actually create our network packet. Okay, guys? Okay, so that's one example. This is what type of a packet? Oh, sorry, I'm sorry. So this one should not have C. So that was a mistake. That would be wrong, correct? Now, if I ask you, what type of a packet is this? What packet is this?
ICMP.
ICMP, exactly, very good. Now I create another packet, PKT2, let's say, and this one I'm gonna create as A /C. So it should be pretty obvious. This is a TCP packet. Okay, And so that's how you can create your individual packets. Let's think of another one. Another way of doing this would be to create, let's say, packet 3. Oh, sorry, PKT 3. Right, and instead of using the letters, we can directly do IP and also TCP, like that. Okay, so this allows us to basically create our individual packets. So in this case, I can do now DST, specify another IP address, so 190 or 205.215.116.11. Right, let's say that's the destination IP. We don't care about all the other stuff. It'll just have default values. Now we could also do against subnets. So we'll take a look at that in a second. So there are other variants, but generally speaking, this is the simplest. And then on the TCP header, we can specify what? Things like the destination port. Okay, so in this case, I'm going to be sending to port 8. Okay, and then also, flags. So our flags here are going to be, for instance, the S flag, right? So a SYN flag, and I can specify here. Okay, so from the three-way handshake, for instance. So this would be a simple TCP packet against port 80, just sending a SYN flag, for instance. Other possibilities are to use wildcards, so you can do something like asterisk, which would attack a subnet, basically. Another approach that has been supported is something like, something like that, a range of packets. So Scapy can be pretty simple to help you out to do things. Are there any questions about this, guys, so far?
I don't have any.
Oh, great. So that's kind of the idea. Let's just look at another one here. Let's do a UDP one. Okay, so I didn't, I guess, add UDP here. Just add D equal UDP, like that. All right, so just to give you another example, I'm going to create packet 4. And this is going to be IP, right? And then this needs to have the UDP header, okay, just like that. So then we can do here the destination, PST. We're going to specify that we want let's just say 10.0 or 1.1.99. Okay, and then on the UDP side, we're going to specify destination port equal 0. Notice there it's a number. What is port 0? Do you guys know?
Port 0 is just like a null port in general, right?
Well, I think this is, that's a good question, actually. Well, yeah, so the best way actually is we're going to test this. right? So we're gonna see what it attacks. I think it's related to ICMP. I think it's targeting, because these are initially UDP packets, but they might be targeting ICMP. So we'll, or something, or it might just generate a response that's ICMP, but we'll take a look at what it does. Okay, so now we've learned a little bit about how to create these. So let's see what else we can do.
Is the destination IP for packet 4 supposed to be in the quotes, or is it like that for a reason?
No. That's
Okay.
fine.
Oh, okay.
Should be like that. It's a string basically. Okay. See what else do we have here? So let's look at one more. If we wanted to craft another packet here, let's do packet 5 equals, and then here, notice there is also obviously the Ethernet header, right? So if you needed to specify, usually for most of the class, we won't be needing that, but you might actually, if you wanted to also address that layer. So there's Ethernet, then there's IP, and then we can have, let's say, a ping packet ICMP. Right, so all we have to specify here is what we want to target. So in this case, you can also try DS destination equal, and you could do www.google.com. Okay, and hopefully you'd be able to ping Google that way. So now let's try one of those functions. So I'm going to get out of here and I'm going to create a new script for this because I want this one to run. -L. And we're going to try the SR function, right? So the functions that we define as sending and receiving a packet. So let's go ahead and try one of those. So let's call this send and receive, maybe. Let's just say send. Simple send. .py. Okay, so we're going to try here then import, or sorry, from Scapy .all import all. Okay, and then now we're going to do p equal, we're going to call one of those functions sr1. Okay, and hopefully this will send and receive back. So to keep it simple here, I'm going to do pkt equal, I'm going to create the packet IP, and this is going to be a ICMP packet. Okay, and we're gonna say the destination now, because this is real now, we have to think of something. Keep in mind, remember, guys, this is only for like schoolwork, internal things, so don't start using this on campus. So we'll do this computer, 127. 127.0.0.1. And that should generate, that should be the packet. So now we need to plug that packet in here, right? Because we're going to be sending it. And then if we should get a response back in P, if P is not null, basically, 1, 2, 3, 4, we are going to do P.show. Okay, so let's go ahead and run this script. Python 3. Operation not permitted. Finish sending one packet. Okay. Should we try something else?
You need to
You need to
give
give
it
it
a
a
payload.
Payload?
Also won't yeah, or also won't send, so like some kind of message. I think in the lab, it had like hello Google or something like that. And otherwise it won't work.
Okay, so let's see.
So you would do like after ICMP, the M parenthesis in ICMP, you would do /
Oh yeah, I see what you're
and
saying.
then a payload.
Payload, okay.
Not the word payload, just in quotes, something you wanna send.
Mhm. Like this, correct?
Yeah,
Hello, Google. All right, so let's try that. So we're sending, but it should have gotten some response. Well, let's try an actual proper, maybe it needs to go to Google. Other DNS server.
yeah, that works.
Okay, there we go. All right, great. So maybe it just needs to be, not our own machine. Does this make sense, guys? Any questions, I should say?
No questions for me.
Pretty clear, right? Okay, good. So as I said, today is just kind of an introduction to kind of feel out how this works. So I'm trying to give you things that you might need. So let me give you a few more things, and then we'll start working through the lab. So we tried Scapy, we listed all the layers. Remember to list all the layers. You can look at ls with parentheses. So that's a useful tool. Let me see. I'll go over that in a second. All right, so that's a quick introduction to Scapy. So we're done. All right, so I think we're ready then to just go into the handout, actually. So let's take a look at the handout. So I'm going to switch back to Brightspace over here. So I'm going to save this script. Okay, I'm going to do clear here. Now let's share the handout. Oh, there it is. So you should be seeing Brightspace, basically, I think. All right, so as I said, I kind of motivated that you have to solve this problem. You have to think about it a little bit. How are you going to deal with it? You'll have a week for it. And then I'm giving you some tools here. So you'll probably install these are graphing things. So the idea here is you're talking about the network. So this might give you a sequence of traces, right? So that might be useful. We've installed Scapy. You know, here, if you run the ls command, it will list all available layers that you have to create packets or analyze packets. Basically here, we looked at the sniff function where you can grab the interface. You can also use these lambda notation that's in a computing kind of a thing instead of writing a function. But today I actually showed to write a function, but you could also do this. This is just computing. This has nothing to do with Scapy really. Then we talked about this one, sending an ICMP packet. So we use the SR1 function. And this is, remember, send and respond. So basically, we created an IP packet for the DNS server of Google, and we send the packet out, and then we show if we got a response. We added the payload as Dakota suggested. So we have IP header, ICMP header, and now we have hello Google, right? And we have something like this. Now, as part of the assignment, you will do this exercise. So this exercise, I'm not gonna do. I'm just gonna leave it to you, but it should be kind of fun, right? So the idea here is, since we were able to establish that we can send that packet and receive a response, now if you are networked, you may be able to communicate with your friend, get his or her IP, then send packets with your own payload message. On the receiving end, they can set TCP dump to listen to the message. And so basically, although this is obviously totally unencrypted, you would be able to communicate just by running, you're literally sending ICMP packets and putting a message on the packet. Is this clear what you have to do here?
Yeah.
All right, so that's going to be part of your homework assignment. Okay, good. So it sounds like, so just play with, basically this lab is just about playing with. All right, so here's a command such as TCP dump. You can see here it's got all these flags, and this is a filter. You're listening in to ICMP. All right, so think about what this can give you, TCP dump, and then, you know, obviously that's another way of sniffing data. You can collect data for a while using the sniffer as well. There's also this command, the A summary. So take a look at that one. When you capture some data, instead of .show, try to use the end summary function and see what it provides for you. So answer the question, what do you see? Now, for the visualization stuff, you can try these, okay? See if you can figure out how to make it work. So you can also do some very nice networking visualization of trace routes. If you install those two programs, GraphViz and Image Magic, I think it was. Image Magic. And this example is borrowed from the official Scapy documentation. So try, so obviously this is within Scapy. You'll do a trace route of Microsoft, Cisco, and Yahoo, and some other ones. And then using that information, see if you can't get a nice little graph, you know, by running basically your res.graph. But Scapy would need those libraries in order to work, okay? And so play around with this, try a few other examples, okay? So you guys have done, I'm sure, traceroute before with the traceroute program, but now you're just doing it through Scapy. The nice thing about this is it would allow you to capture data, visualize it nicely. And this may or may not help you with the case, okay? So this may or may not help you with the case. So let's see now. So I provided some problems or examples today. We went over Scapy. All right, you can disregard this last third item. I'm gonna remove it. Not even sure what I meant by it, so I'll take it out. And then, of course, that just leaves then now the Ph.D. Moore problem. How do we solve that one? So any ideas? What do you guys think? Oh, okay. It's there, you don't need more. I think, you know, honestly, the reason why I cut it off is that the following thing provides the solution. So I just didn't want to have to type it up again. So this should be complete in order, yeah. This should be complete in order for you to try to solve it. But before you even start writing code, you need to think, right, about how we can solve this. So that this is why it's a case. So I'm asking you guys, what do you think? Any thoughts? And I'm going to pause it here. Pause the video recording. So if so, going back to the case, what the Pentagon is trying to do is trying to figure out who's end mapping their network, right? So now one way it says here, an nmap scan proves rather easy to detect, correlate to the attacker's address, and then geolocate that IP address. So geolocate just means that when you have an address, you can say where it came from, right? You can figure out, oh, this is from Hammond or Chicago or something like that. But you need to have the source IP, because the packet, every packet that's coming into the network, it's got a destination IP and a source IP. You really don't care about the destination IP because that's you, but you definitely would care about the source IP. If you had the source IP, you could trace it back to the attacker. Do you guys see that?
Yes.
All right. So then, however, the attackers used an advanced option in Nmap. Instead of just sending scans from their specific attacker addresses, let's say their home in Hammond, they included decoy scans. They were basically doing like a massive attack, right? A massive attack, and they have decoys, so they spoof packets. So some of the packets had fake source IPs. So that's the critical point there. So instead of just sending scans from their specific attacker addresses, they included decoy scans that appear to originate from many places around the world. So the IPs, because they were spoofed, they were coming from all over Europe, Latin America, Asia, Africa, everywhere in the world, right? And so the Pentagon experts had difficulty distinguishing between actual scans and decoy scans. So somebody asked me, what's the problem? That's the problem. So while experts poured over massive reams of data logs with theoretical methods for analysis, it was really a 17-year-old from Austin, Texas, who presented a working solution. Okay, and that's as far as the story goes. So now the question is, how do you figure out fake packets from real packets? Do you understand, guys?
Yeah.
So, okay, so that's the question. Okay, great. So now you have to think about how you would solve this. You know, what would you do? And then, of course, you don't just have to say in words how you solve it. You have to give me a working implementation that shows evidence that it works. So you're going to have to do this. You have to do kind of an attack like this, where you can create the packets with Scapy if you'd like. Then the packets have to be something, and then you have to solve the question, basically. Is it clearer now? So what are some ideas? So this is where I want you guys to kind of, do a little bit of a brainstorming session and tell me what you think.
To my knowledge, TTLs are the best way to identify decoys.
Okay, what would you suggest?
I don't know off the top of my head what the standards are, but I'm pretty sure that there are some standard TTLs or initial TTLs for packets. And what you can do is using traceroute, you can see what the time to live values are on some of the attacking packets. And if they kind of add up to a TTL that seems abnormal, there's a pretty good chance that it could be a decoy because it took an abnormal route potentially. So trace route and a little bit of math probably be my best guess at the start.
Perfect. That's a great idea. Exactly. So that, I would say, that's the way to go. And so now, as I said, in this, you'd be, so I know it probably sounds very complex, but it's actually quite straightforward once you implement the code. Okay, so that's the homework assignment. Okay, so now I'm going to go ahead and create on Brightspace, I'm going to create the link. And this is what you have to work on. So it's going to be under Scapy. This is the first week, so I'm going to add the new assignment. And we're going to call this Scapy H.D. Moore. So double M Moore case. Okay. Solve the attached case on H.D. Moore's dilemma. Okay. Oh, here it is. Okay, so solve the attached case on H.D. Moore's dilemma using Scapy and Python. Provide a solution and show that it works. Okay, so this is 100%, and it's gonna be due. So today is the 13th. So it's gonna be due on the 20th, a week from today, by 10 p.m. This is gonna become available now. It'll stay open until the 22nd. Okay, so that's it. Is this clear enough, guys, of what you have to do?
So you want us to actually like do a decoy scan and show?
You have to do something. It doesn't have to be like an actual attack. Don't attack the Pentagon. I'm not saying that. So I want to make that disclaimer very clear. It's some kind of a simulated thing in your environment with your VM. But something, write a little bit of code, something that the whole pipeline of everything that we're going to do this semester is you're going to have to generate some packets that kind of simulate the attack. So in this case, what is the attack? The Nmap scanning, correct? And it's got to be a little bit of spoof packets in there, right? And then I showed you how to create packets. I also showed you the send and receive, right? So or sniff and do something. So then you would have to capture some of these packets as you suggested, Dakota, look at the TTLs in some logical way, and then kind of filter out, as you said, it's a way of reducing the range, right? And we can focus, because you said some of the TTLs will look more fishy than others. So filter out the fishier packets. Do you guys see what I'm saying?
Yeah.
Yeah. So this is what I want you to work on. And, all semester, this will be pretty much the pipeline of what we have to do. Obviously, I'll provide a little bit more information later, but I want to see you guys work through this problem first. So this is clear enough, correct? I can say this?
Yeah.
Okay, great. So it sounds like it's clear. So it should be a fun exercise. A lot of these exercises, as I said, can usually be simulated with two terminals. I'm not really looking for anything too complex in terms of the network, but really the point is that there will be some packets going in one direction, some packets going in the other direction, and then you have to deal with them. So I feel like I've given you all the code that you would need to get started with this. Let me just see if I missed anything. So for instance, let me just, I guess, give you a little bit more. The recording will be online sometime later tonight. Yeah. Okay, so let's see. So just kind of a few hints, right? So what could you do? Now remember, what could be an easy way to do the attack? Well, the problem says that Nmap could generate multiple packets. There might be a flag in there to generate spoof packets. Do you see what I'm saying? So maybe you can just leverage that tool without having to write code for it. Correct?
Yeah.
Okay. Second, now, so that means, what about writing the code, right? So the sniffing code. So what would be just like a basic approach? Let's think about it. So I'm going to do nano let's call it HD more. Right, and I'm just going to give you like a basic pipeline. So I'm going to want this to kind of work. So obviously I'm going to do from Scapy dot all import all. Right, so I got the library. And then you have like TTL values, maybe like a list, right? Because you mentioned that you want to take that approach with TTL values. Obviously here you need something like sniff, right? And the question is, what are you going to be sniffing for, right? So maybe figure out a filter, right? Maybe. And then also, what do you do with the packets that meet that condition? So then here, let's say you create a function, something like test the TTL value, let's say. Sorry. You see that? So that's kind of the intuition. So then, of course, you have a function test the TTL value. Now, the question is, where is the TTL in a packet? You see that? That's an important question because you want to know which header to look at. Let's do the indentation. 1, 2, 3, 4. Okay. And so now here you have to write your own code that specifies, okay, what layer this is located in. Okay. And where is the TTL, where do you find it? So if you put a filter that's very specific, it'll narrow down the packets that you're capturing. So it'll make this part easier because it might just be as simple as I'm going to get TTL value, right? And that TTL value is going to come from PKT. Maybe what? Maybe you're going to get the dot IP header, right? Something like that. Then you could say my IP, for instance. I'm not saying that's where it is, but maybe. Right? And then after that, oops, sorry. And then after that, TTL my IP, for instance, dot TTL. So this is generally the way this should work, okay? So you're gonna get the TTL value of a packet. So that there you have something. For instance, so now you can think about, okay, what can I do with that packet? Does this make sense, guys?
Yeah.
All right. So I don't want to give too much of this problem because then, I want you guys, I literally want you to you're going to have to Google, okay, how could I use TTL to distinguish fakes? And then after that, try to implement the code. And then after that, try to provide a working example of this. Okay, so that's basically the problem. All right, so I'm going to go ahead and save this file. All right, so today is lab, so let's use the remaining. I don't have any additional code to give you at this time. So let's use the remaining 10. So I'm going to actually pause the video now.